Can you hear me?
Yes.
Okay, right. So you cannot do the integration using substitution. Okay, so this I have already shown you a few using substitution, right? This one, the whatever that is inside the square root, we call it u. Well, because there's a square root there, you have to use u square, right? Then also this one like that. This one no square root, so you just use u alone. So depending on the question, whether there is a square root or cube root, or whether there is no root at all, so we choose different type of substitution so that we can simplify the question, so that it can become a function that is easy to integrate, right? So we go back to this question here. This is provided in your lecture notes, the first one, right? We go back to the first one. Okay, so we have integrate x to the power 4 plus 6 raised to the power of 3. You see the bracket raised to the power 3. Then beside this bracket, there is 4x cubed dx. Okay, now you look at this question, what is it that make it difficult to integrate? Because of the bracket raised to the power of 3. So if we use the bracket raised to the power of 3, we don't know how to integrate, right? Because inside is another function. Probably this is a composite function. We can look at it as if it is a composite function, right? Consists of x to the power 4 plus 6 as one function, and the whole thing raised to the power 3 as another function. So the thing that makes it very difficult is this x to the power 4 bracket raised to the power 3. So what type of substitution should we use? So in general, whatever that is inside the bracket there, you call it u. You call it u so that this whole thing can become u cubed, u to the power 3. Once it becomes u to the power 3, then it's very easy lah. Become u to the power 4 divided by 4, right? That's how we integrate. So we try to change this to u. Then you may worry, hey, there is this 4x cubed there. Is it going to pose a problem to us when we try to integrate? You don't worry about this 4x to the power 3, because when you use the substitution, and this thing will become du. This whole thing, x to the power 3 dx, they will become du. So you are actually integrating u to the power 3 only. Okay, so one more time. Next time when you encounter this type of problem, whatever that's inside the bracket, you call it u. You call it u. Okay, so now we let the u become x to the power 4 plus 6. So when you call u x to the power of 4 plus 6, then this thing will become u. This thing will become u. So your problem is solved. It's very easy to integrate now. Then you may worry about this 4x cubed. Then we look at the next step. When you differentiate u with respect to x, this thing becomes du dx. X to the power 4, when you differentiate with respect to x, it becomes 4x to the power 3. Okay? Exactly here, 4x to the power 3. Then you differentiate 6 becomes 0, no more already. So this is du dx is 4x cubed, 4x cubed. Okay. Now we need to find du, or rather we need to find something to replace this dx here. Because when you change this to u, you cannot integrate u with respect to x. When you change this to u, the dx also need to be changed to u. So that's how we come up with the u. You separate them, du, then the dx you bring over. So you see that, oh, du is 4x cubed dx. Now, will this help us? Is this going to help us? Sure, it's going to help us, right? How? So when you want to integrate x to the power of 4 plus 6 raised to the power of 3, this thing is actually u. I get my tools here. Okay, right. What color is this? Green color. Okay, now my green color. So, okay, when you use the substitution, x to the power 4 plus 6 is u. So this whole thing becomes u. This whole thing becomes u. Okay, so grade this, and this one become u. So it had become this u here. Become this u here. Then they say raised to the power 3, you keep the power 3 there because we only substitute x to the power 4 plus 6 with u. The power of 3, we didn't say it belongs to the u. So the power of 3 is still there. The power of 3 is still there. Then you look at this dx. 4x cubed dx. So this 4x cubed dx is exactly our du. So this 4x cubed dx is actually exactly the du here. So now from a very complicated integration, where you have bracket raised to the power 3, beside the power 3, you have x to the power of 3 again. It looks like very difficult, but it becomes a very simple problem like this. Right? Integrate u cubed du, that's all. Because everything you change to u, it becomes simpler. Now, if you ever do an integration using substitution, and the substitution become a more complicated function, then your substitution is wrong, right? So when after substituting, everything must be very simple. Like this, integrate u to the power 3 du. This is a very simple integration. U to the power 3 du is what? Can you tell me? Integrate u to the power 3 du.
U 4 over 4.
Correct. Then divide by?
Divide by 4.
Correct. So it's as simple as that. So we see correct or not? Oh, yes. It becomes u to the power 4 divided by 4. Of course, there will be, because this is an indefinite integral, there is no upper and lower limit. So you have to put down the arbitrary constant plus c there, right? Plus c. So that's all. But you cannot leave the answer in terms of u, although this is correct, right? U to the power 4 divided by 4 plus c. But the question gives you as x, you don't give them answer back as u, right? No? So you have to change this u back to x. So how to change the u back to x? So this u, you change back to this one. X to the power 4 plus 6. Because we said u is x to the power 4 plus 6. So the u here change back to x to the power 4 plus 6. So the other things like the 4 here, the 4 here, don't change anything, right? The C here, you leave it back as C. You don't change, only change back the U, that's all. Other things don't touch, you just leave it as it is. So the answer is 1/4 x plus 4, x to the power 4 plus 6 raised to the power of 4, then plus C. So you go through these steps, right? Go through these steps. What type of substitution I must use? What is inside the bracket there? What is beside one? You don't worry about it. It will become the du, right? So you go through this step again, how to replace. Then I give you the second problem, this one. Your lecture notes from your lecture notes, right? So you try this question. You look through this question first. Okay, then you tell me okay.
Okay.
Okay, right. Now, if it's okay, then we look at your question here. The question given by your lecture notes, your lecture notes is like that. Integrate t square cube root of 4t cube minus 3 dt. What type of substitution you are going to use? Let's say I start with u. Right? U equals to what? So you will think that, oh, u is equals to 4t cube minus 3, right? 4t cube minus 3. Oh, if you use 4t cube minus 3, you will still have this cube root here. So you are actually integrating cube root of u with respect to u, or something close to it like that. Normally, we don't want to handle the square root, the cube root, and so on. If possible, we try to eliminate the square root or cube root. Now, in our previous example here, when we encounter the square root, like this, right? Like this, sorry. So I don't call u equals to x plus 1. I call u square equals to x plus 1. Why I want to use u square? Because when I put the u square inside here, then the square root of u square, they will cancel each other. So there will be no more square root there. Okay. So using the same method, because there is a cube root here, I don't call u equals to this thing. I call u cube equal to this thing. Why is it that I use u cube instead of u? Because when I put the u cube inside the cube root sign here, the u cube and the cube root, they will cancel each other. I'm only left with u. Okay, so when I left with u, it's very easy to integrate. Well, then you may think, there's one t square here. Then the t square, I don't know how to integrate. You don't worry, because when you find the du dt, this t and the t square and the t will become the du. So you don't have to worry about this, right? Oh, can you proceed from here, or you need me to show you one more step? You can refer to the thing here. I already tell you. Huh?
I try and see.
Okay, you try and see. I give you let's say 5 minutes. By 5 minutes, you cannot do then 7 or 8 minutes. You show me whatever. If you cannot complete, then you show me whatever you have done. Then I will continue from there. 8 minutes the
Mm.
most. If you can faster than 8 minutes, then okay. Okay, right. So we have U, yes, very good. dv or du dt. This one is this part is correct. This part is wrong. So I show you. D you use U equal U cube, correct. This one not nice, this color. This color, okay. So so you use U cube equals to 4D cube minus 3. Oh, your differentiation is wrong, right? Well, when you differentiate U with respect to t, you get du dt. But this is not U, this is U cube. When you differentiate U cube with respect to t, you have to use implicit differentiation. So the implicit differentiation is 3u squared du over dt, du over dt. And on the other side, when you differentiate, 4t cubed is 12t squared. 12t squared. Negative 3 becomes 0 already, right? So this is the type of differentiation. So when you separate them, you want to find dt, right? dt. So it will be something like this, right? So this one, you remember this, okay. So I'll clear this. Then move to this page. Okay, right. Now, when you let u cubed equals to 4t cubed minus 3, what do you get? You have to do an implicit differentiation because you are differentiating u with respect to t. So you have to differentiate the u first. Now, normally, if it is just u alone, then you will get du dt because the u will become 1, right? But now it's u cubed. U cubed, you have to make it 3u squared du dt. And this side is 12t squared. When you separate the du and dt, you will have 3u squared du minus, equals to 12t squared dt. You separate the du and dt. If you look at the question here, it is t squared dt. T squared dt, but here we have 12t squared dt. So what is required by the question is t squared dt, not 12t squared dt. So the 12, you have to move to the other side. When you move the 12 to the other side, then you are left with t squared dt. You are left with t squared dt. Then the 12 will move over to the other side. So you have 3u squared du over 12. The 3 and 12 can cancel. The 3 and 12 cancel. You get a 4 here. You get a 4 here. So next. So actually, what is required by the question is t squared dt. And this t squared dt is u squared du over 4. So this t squared and dt, it will become the whole thing like this. Okay. So you look at the question. The blue color, 4t cubed minus 3. Because we say 4t cubed minus 3 equal to u cubed. So the blue color is u cubed. We only do accordingly. Things that is not there, don't try to change the question. Right? So the cube root is still there, so you just leave the cube root there. We only do the blue color only. U cubed, that's all. Then the orange color, t squared dt. We have found out earlier that t squared dt is u squared du over 4. U squared du over 4. Okay. So this cube root of u cubed, they will cancel away. So you are left with u. The u here and the u square here become u cubed. So what you are required to do is integrate the u cubed. You look at your answer. So your answer is you call the dt equal to du, right? So this dt equal to du is not correct. T square dt is what? T square dt, sorry, your t square dt, this one, d square dt is du. So it's not correct. Why is not correct? Because it's not the du, but it is u square du over 4. So this part is wrong. This part is wrong. This is not du. This is u square du. Some more got a 4 there. Got a 4 there. Because your differentiation here is wrong, right? So like that. So you think that this you integrate the u become u square, but in fact there is don't integrate u. It's actually integrate u cubed. Actually integrate u cubed. You want to continue from here? Continue from here? Or you want me to show you?
Show me.
Show, okay. Okay, so we go back to the next one. So after substitution, it becomes like this. d square dt is u square du over 4. This part you did correctly. So this one, how to simplify this? Okay, this one is actually u. The u square, I put u square here. The 4, I put 1 over 4 here. Then the du, I put back in u. So I didn't change the question. I just follow accordingly. What is there, I just replace. What is not there, I didn't put there. What is already there, I didn't throw away. That is very important, right? What is there, you just leave it there, right? What is not there, don't add, just substitute will do. So this one, it becomes u times u square is u cubed. So it's 1 over 4 u cubed. So you know how to integrate u cubed. What is it? Integrate u cubed.
U cube, u3, divide 3.
And this is 3 already. This is 3 already. So what is it? U what? U
U3,
cube integrate become?
u4,
U to the power 4 then?
divide 4.
Correct. U to the power 4 divided by 4. So it becomes u cube become u to the power 4 divided by 4. The 1 over 4, we didn't do anything, is still there. So when you simplify, this is 1 over 16. The 4 and 4 is 1 over 16. U to the power 4 plus c. These are very simple, right? Now the problem is how to change back to t. How to change back to t, right? Okay. 1 over 16 is still 1 over 16. 1 over 16 is still 1 over 16. Now u to the power of 4. This is 4 already. The 4 is here. Then what is u? What is u? From this equation here, u is actually cube root of 4t cubed minus 3. Right? So u cubed is 4t cubed. U is cube root of 4t cubed minus 3. Then I substitute back here. So this u is actually this cube root. cube root of this thing. Then the 4, I didn't change the 4. I only replaced the u inside. Okay. Then the 4 outside looks very weird. Huh? So I put the 4 inside. So it's the cube root of 4t cubed minus 3 raised to the power of 4. Raised to the power of 4. Then, okay. So, instead of writing like this, I write it this way. Then plus c. So this is integration using substitution. Now, if you notice, the question here is indefinite integral. But all the questions later on, they are definite integral. So from indefinite integral, they change to definite integral. So I have not taught you how to do this definite integral yet. So we now switch to definite integral. Right? We should switch to definite integral. Okay. Okay. So how to switch to definite integral? Huh? Oh yeah, I didn't